All right, section 2, here we go. So looking at some lengths to start things off. Remember, these are notes that you guys can always print out and use, so you don't have to try to write all of these things down. But examples 1 and 2 are up here for you, so I'll let you take a look at those. This first part is really just kind of like basic use of like a ruler. If I was going to measure something, you can see this one is in centimeters. Obviously, it is 3 full centimeters. And then we're going to need a fraction to take care of the rest of it. So how do we set up a fraction for that? So if you look in between numbers, you would count how many little lines there are. So if we counted them, so there are 10. So there are 10 lines from 3 to 4. So that means these represent, each line represents 1/10. So as I look at this, I can see that it's at 1, 2, 3, 4 tenths, right? So we could say for this one that it is 3 centimeters and 4 tenths. So we can do that one. Of course, you could reduce that to 2 over 5. So that would work. If we wanted to do, so this is if our answer wanted to be in centimeters, right? Because we're using the big guys for centimeters, so it's 3 2/5 centimeters. If we wanted to put it in millimeters, because they are going by tens, the next unit down from centimeters would be millimeters. And so if we really wanted to, this would be 10, 20, 30, plus another 4 millimeters. And so that would be just another way of putting it. So that would work. We could also put it in centimeters, and that would work too. So you'll see another one over here on the right. So the length of RS, really the same thing. So this one is in inches. Because there are 1, 2, 3, 4 marks per inch, I know that each little mark represents 1/4 of an inch. So on this one, we can see that we have 1 full inch, and then another 1, 2, 3 out of the 4 remaining for inches. So that's where we're getting the 1 3/4 inches. So for these guys, always good when you're doing these videos. At this point, you can always just sort of pause and try this on your own and then see if we get it right. So on this one, you could do it like the one up above, and because they are counting by tenths, there are 10 little lines in there. That means if we wanted to, because it's by tenths, we can bump to the next unit down, which would be millimeters. So you could do this in centimeters, right? It would be 1, 2, and then 5 out of 10 centimeters. So we could write it as 2 5 tenths. Which of course could be simplified. So we could write that as 2 1/2 if you reduce your fraction. If you really wanted to go decimals, you could say it's 2.5, but all of these are done in centimeters, right? We're going off of the big numbers, which were centimeters, so we could write it that way. If you wanted to go millimeters, you would have 10, 20, and then another 5, so 25 millimeters. So we could go that route too. If the directions don't say which one to use, then either one should be correct. Obviously, if it's a multiple choice scenario, kind of good to know how to do both because you don't know which version of that answer you're going to see. So it's good for multiple choice cases to know how to do it both ways. That's my doggy in the background squeaking his squeaky bone, so if that's what you're hearing. Anyway, our next one is done in inches. So you can see it is 1 full inch, and then one more little line. Because there are 1, 2, 3, 4 lines per inch, I know this is 1/4 of an inch. So we're going to say it is 1 1/4 of an inch. If you wanted to go with an improper fraction, you could say it is 1, 2, 3, 4, 5 fourths of an inch, and that would work too. So either one of those would be okay. Well, let me jump over to the next page. So here now we are going to start taking a look at some segment addition. Super big part of geometry is adding these segments. This will come up within future chapters, so this is a really important one. The main idea on this is what we're seeing right here. So segment addition is where you are adding 2 smaller segments to equal a bigger segment. So if you were to look at this guy over here on the right, So you can see there is a segment PM, there is a segment MQ. If we put both of those together, we get the whole thing, which is segment PQ, right? So if I add this one plus this one, I get the whole thing, which is PQ. So this is the equation, the model that we want to use to set these up. I'm going to go through this example once we get to number 3 down here. So let me start out with just what we talked about, because this is mostly what you'll see will come from something like this. So here's something I would strongly recommend. You see the equation that they wrote here that we just talked about. I would strongly recommend writing that first for a problem like this, and then plugging in what those segments represent. So if you take a look at this example right here, first thing they did was write the equation. So we have ED, then we have DF, and if you add those two segments together, you get the whole thing, which is EF. So they started by just writing that equation. Then you replace the letters with what they represent. So we can see that ED is the 1.2, so that went in right here. DF is 1.9, that went in right here, right? And then we have EF, which is the whole thing. That's what we're trying to find. And then when you solve the equation or simplify it, we have our solution. So when you get to ones like this, here's where it gets a little bit harder, and this is why it really helps to write out the equation first. So that's what they did here. So we have AB, we have BC, and if I add those two smaller segments together, I get the whole thing, which is AC, right? And so that's where we want to write the equation, and now plug in the information for what they represent. So AB, we're told right here, has a value of x, so that's going in for AB. BC is 2x, so that's going in for BC, and then right here it says the whole thing is 2x plus 5, so that gets subbed in for AC, and now we just use some algebra to solve the equation. So combine like terms, you got your 3x, subtract 2x from both sides, and we have our value for x. One thing you have to be super careful on, especially for a test or a quiz, is read very carefully what they are asking you for. Sometimes they are just asking you for x, but other times they might ask you for something more. So this one is asking for AC. Now that I know that x equals 5, I can now go to my value for AC, and I can replace my x with a 5. So 2 times 5 plus 5 is going to give us our answer. So that's what we're seeing right here. So that's our value for AC. So here's where you can pause and try numbers 1 and 2 on your own, and then I'll come back with you for number 3. So if you gave number 1 a shot, I would have started by saying RS plus ST equals RT. And I'm going to plug in the information. RS is 2. ST is 2.5. And we're going to add those up to get RT. So if I add those together, I get 4.5 equals RT. And number 2, again, I have AB. I have BC. Those are the two smaller ones. The whole thing overall is AC. And now I'm going to sub in the information they gave me. So AB is 2 3/4. We don't know what BC is. That's what we are solving for. So I'm going to leave it as BC for now. Right here they told me the whole thing is 6. And now I just solved the equation using a little algebra. I would subtract this from both sides in order to get BC by itself. So on the right side, I have to figure out what 6 minus 2 3/4 is. So this is where you get to go back to your good old algebra and do that subtraction in order to figure out what BC is. So if you do that, we would get 3 1/4 as our value for BC. Okay, so this one over here, what do those little lines mean? So really big concept in geometry. Those little segments are called congruent marks or congruency marks. This is a symbol for congruence. Congruence is pretty much the same thing as an equal sign. But when you are discussing a length of a segment, but not necessarily a value, then we use a congruent mark, right? So if I wanted to say that these both have the same length, then I can say that they are congruent. If I wanted to say they have equal values, like this one is 3 and this one is 3, that's when I would use an equal sign when I'm dealing with the actual value. So hopefully that makes some sense. Ask me if it doesn't and I'll go over it again. But the congruence marks, like I said, it basically means they're equal, right? So when I see those little marks, because they both have the 2 mark, I know they're equal to each other. So this one has the same length as this one does, right? So that's why we're seeing the little congruency stuff. So I know that WX is equal to or congruent to XY. I'm going to leave an equal sign because I actually want an equation to solve, right? So I don't know what this is. I don't know what this is. This one is super easy because obviously if the whole thing is 6 and these guys are equal, they're both 3, right? So that would be really simple. But you're going to get some that are not so simple. And so I'm trying to give you a way that you can solve the ones that are harder. So I'm just going to call this guy, and they already got an X in there, so I need to call it something else. Let's just call it A. So this one has a length of A. So does this one because they're congruent to each other. So I know that A and A equals 6, right? Because that's the total length. If I did my algebra on this, 1A plus 1A is 2A. And if I divide both sides by 2, I get my answer. So, like I said, this one was much simpler to do in your head. You could figure out if these are equal, they both have to be 3 because I'm just dividing this by 2, which is what we ended up doing anyway, right? We're dividing the 6 by 2. This is just more of an algebraic approach for some of the cases that might be harder, right? And so I'm trying to give you an approach to some tougher cases. Go down to number 4. These are going to be our last 3 here, so stay with me for 3 more. So this one comes without a diagram, and in geometry, diagrams make a giant difference, so I would always encourage you to draw one. This one says that S is between R and T. So if S is between R and T, right, it doesn't say it's in the middle, so we don't know necessarily that this is equal to this. It just says it's between them, so it could be anywhere between them. So as far as our segments are concerned, we know as far as our equation goes that RS plus ST make up the whole thing, which is RT, right? And then this is where I would sub in the information. So RS, they were telling us, is 2x. ST is 5x plus 4. And RT is 32. And we're just solving that equation. So use your basic algebra, combine like terms. So 7x, subtract 4 from both sides. And we're going to get x equals 4. Again, be careful on these, right? Make sure that that is what they are asking for. And this one did say what's the value of x, so we're good. But if they ask you for something else, like RS, we got to go one more step. So remember, RS is 2x. So we just figured out that x is 4. So that means RS is, I'm going to replace my x with a 4. So RS is 8. Right, so read careful, make sure you do all parts of what you're being asked for. Last 2, determine whether each pair of segments is congruent. So remember, congruency just means they have the same length. Once you put in the actual value, now we're talking about an equal sign. So then we're saying they're equal. So is AB congruent to CD? Do they have the same length? So if AB equals 5 and CD equals 5, so if they are equal to each other, then we can also say they are congruent to each other. So yes, we would say that AB is congruent to CD. Just a side note, geometry can be very picky when it comes to notation. Whenever you are using a congruent symbol, then we also want to use the segment symbol, right? Whenever we are using an equal sign, so if I said AB is equal to CD, then we no longer use the segment symbol, right? Once we say they're equal in value. So weird little picky little details like that, but important to pay attention to. Is XY equal to YZ? So is XY and YZ congruent to each other, right? Well, remember what we talked about earlier. See those little marks right there? Those are your congruency marks. That means these two guys are equal to each other, so we know that for sure. But we don't know about this one yet. This one says 9x over 2. Well, let's just start with what we know. I know that these two are congruent to each other, so I know that 3x plus 5 is equal to 5x minus 1. If I solve that equation for x, so I'm going to subtract 3x from both sides. I'm going to add the 1, divide by 2, and we know that x is 3. Well, if x is 3, let's come up with some real values. This guy is 9 times 3 over 2. So 9 times 3 we know is 27. 27 divided by 2. I'm just going to leave it as 27 over 2. So is that equal to those guys? So if I plugged in a 3 for this I should do xy based on this. So if I plugged in a 3 right there, so if I take that 3, plug it in for that x, I can see 3 times 3 is 9, plus 5 is 14. So clearly those are not the same value. So we would say no for this one. And that is the end of section 2.